At Honors Algebra 2 Pre-Calc, doing section 9.2 in Pre-Calculus, which is arithmetic sequences and partial sums. So in E5, we're given an arithmetic sequence 200, 193, 186, 179, and we're asked to find the 100th partial sum, meaning the sum of the first 100 terms of this infinite arithmetic sequence, which is a lot of terms. Just going to point that out. So, sorry, getting a slightly better marker, maybe. We'll see. All right, so here's the deal. I know that what they're asking me to find mathematically is oh yeah, that is a better marker, S sub 100, right? Which I know should be 100 over 2, right, because that's the number of pairs, times the sum of A sub 1 plus A sub 100. Well, here's the problem. I don't know A sub 100, right? I know A sub 1, that's great. Okay, so I know that this guy is a 200, right? But this is a big old question mark, right? So I can find this value as soon as I know what the 100th term is. So I'm not expressly asked, like they don't explicitly say, find the 100th term of this, but you can't really do this sum easily without finding the 100th term. So knowing that, we're going to find A sub 100 first. So if I want to find A sub 100, remember that the formula for the nth term of this arithmetic sequence should be the first term, A sub 1, which I know, plus n minus 1 times the common difference, d. Well, I know A sub 1 is a 200, and I can see by visual inspection that the common difference is a negative 7, right? So I say 200 minus 7 would give me a 193. Subtract 7 again, I'd get a 186. Subtract 7 again. So I get that my common difference is a negative 7, and I know A sub 1 is a 200, right? And I know I want to find A sub 100, so that means I'm going to be doing a 99 times that negative 7. Now, nobody expects you to do big numbers like this without a calculator. That's just fine, right? So I'm going to do a 99 times that negative 7, which is a negative 693, and I'm going to add to that a 200, and I get negative 493. So I get that my A sub 100 is a negative 493, right? So now, that means that my S sub 100, which is the thing I was asked to find, is going to be a 50, because that's what the 100 over 2 will be, right? There are 50 pairs. And then it'll be a 200 plus this negative 493, right? So I'm going to, again, nobody's expecting you to do that by hand. It's great if you, like, stubbornly want to. But I'm going to take that negative 493 and add 200, so this will be a negative 293. And I'm going to times that by a 50. And I get negative 14,650, right? Again, nobody expects you to be like, yeah, I'm totally going to do that by hand. I mean, like, if you want to be that person, great, but that would be a weird life choice, okay? So again, in order to do this, I had to find the 100th term. There is actually a clever way around that if you want, so I might as well mention it. If you were like, hey man, I'm just not going to do this, you didn't explicitly ask me to do it and I just don't want to, you could actually use this formula to substitute in. So as a cool, like, random side note, if you wanted to be lazy and not find the nth term, you know that S sub n is n over 2 times A sub 1 plus A sub n. So if you really wanted, you could replace the A sub n in this formula with this thing. You'd get A sub 1 plus another A sub 1 plus that n minus 1 times d, right? So really what would end up happening is that you could use the formula S sub n equals n over 2 times 2 of the A sub 1 plus whatever n minus 1 times d is. And again, that would be a shortcut that allows you to jump right to this answer, right? Because if you did that, you'd get that S sub 100 was a 50, right? 100 over the 2, right? And then 2 times A sub 1 would have been a 400 plus a 99 times a negative 7, right? And if you type that in your calculator, right, if you were to type in a 50 and then in parentheses 400 plus 99 times negative 7 and hit enter, you'll see that you get that same 14,650 with a negative that you would have gotten anyway, and that's fine. Again, I would argue that you have to know this formula either way to do that, so however you get there is up to you, but that's one way to do it. And we're going to do some word problems where we need to find the nth partial sum of something in a minute.